Final example, this one's going to be a little bit of a doozy, but this is about as hard as you'll wind up seeing any of this sort of stuff get. All right, police discover a body in an air-conditioned room with a temperature of 22 degrees centigrade Celsius. When the medical examiner inspects the body at 10 p.m., it has a temperature of 33 degrees. At 11 p.m., it is at 31 degrees. When did the person die? And we're also told that human body temperature is 37 degrees. And finally, we're also told to give our answer the nearest tenth of an hour. All right, so what's the idea going on here? The police find this body, and so they can take the temperature of the body at one moment in time, and then they wait a little bit longer, and they can figure out the body has cooled. From that, they can figure out how fast the body cools, and because they know what it was at one time, they can go backwards. They can use the math to go backwards and figure out when was the body at a normal human body temperature. When was the body still alive? And because when it's 37 degrees, that'll be the moment of death. That will tell us when the person died. So this is forensic science. This is the sort of information, sort of math that crime scene investigators can use to figure out when did a person die by being able to create a good murder case based on that. All right, so let's get our pieces of data from this. We're told that the room has a temperature of 22 degrees. So the surrounding temperature of our room is 22. The initial temperature of our body is 37 degrees, right? Human bodies are 37 degrees when they're alive. When the medical examiner inspects the body at 10 p.m., it has a temperature of 33 degrees. So now we've got this confusing thing of time, right? In the last example, we knew what time zero meant. We knew where it was, and everything was told relative to time zero. Time zero was you turn off the stove, and then t equals 10 was 10 minutes from turning off the stove. But at this point, the t equals 0 is time of death, but we don't know what 10 p.m. is to that yet. But let's start off by saying t equals 0 is time of death. So the moment the person dies is t equals 0, and from there we just counting there. So t equals 0 is time of death, so t equals 1 is 1 hour after time of death. Because currently we're dealing with p.m., 10 p.m., our answer was told to be given in hours, so let's work with hours as our form here. So t equals 0 is time of death, so t equals 1 is 1 hour after death, t equals 2 is 2 hours after death, t equals 3 is 3 hours after death, etc., etc. Now, that still doesn't quite tell us what 10 p.m. is, so we're going to have to name symbols for this. So let's say t sub 10 is equal to the hours to get from the moment of death to 10 p.m. And similarly, t sub 11 will be the hours to 11 p.m. Great. With all of these ideas in mind, we're ready to start working things out. So at time 10 p.m., at the time of 10 p.m., which we don't know how many hours it is after death, but we can still talk about it as T10, we know that the body is at 33 degrees at 10 p.m. So we've got 33 degrees at 10 p.m. is equal to surrounding temperature, 22, plus initial temperature, 37 minus surrounding of 22, e to the k T10, because that's our time, so T10. Okay, subtract by 22 on both sides, we get 11 equals 37 minus 22 is 15, e to the k T10. So we divide by that, we've got 11 over 15 equals e to the k T10. Finally, we take the natural log of both sides, and we've got natural log of 11 over 15 equals k T10. Now at this point, we go, shoot. There's two unknowns, and this is only one equation. Well, we're going to have to bring a little bit more information to the table. So let's look at the 11 p.m. hour. So at T11, right? That's not T equals 11, that's T11, which is just the name that we gave to the number of hours after the time of death when it gets to 11 p.m. So how many hours after death is 11 p.m.? So at t equals 11, we've got a temperature of 31 degrees at 11 p.m. So, sorry, not at t equals 11, at T11. We've got a temperature of 31 degrees. And then surrounding environment is still 22, plus initial temperature was still 37, minus 22, e to the k, and now we're using a time of 11, T11. So T11, once again, I want to just point out, it's not time equals 11. It's definitely not that. It's just we named this thing hours to 10 p.m. as T10, hours to 11 p.m. as T11. They could be 1 and 2. They could be 5 and 6. They could be 80 and 81. We don't know yet. We just came up with names for these things so we could start working things out. We can subtract by 22 on both sides. We'll get 9 equals 37 minus 22 is 15 e to the k T11. We can divide by the 15, so we get 9 over 15 equals e to the k T11. Take the natural log of both sides. Natural log of 9 over 15 equals k T11. Shoot! We've got, once again, 2 unknowns, 1 equation. And between all of them, we've got k, T10, T11. That's 3 unknowns, 2 equations. We need some other piece of information that will connect these things together. How is k connected to T10? How is T10 connected to T11? Of course. How is T10 connected to T11? Well, 11 p.m. is 1 hour after 10 p.m., right? To get from 10 p.m. to 11 p.m., you go up 1 hour. So however many hours after death T10 is, we know that if we add 1 to that, we'll wind up being at the 11 p.m. mark. So T10 plus 1 equals T11. This key realization will allow us to solve things. So we can plug this in over here. So we've got natural log of 9 over 15 equals k times T10 plus 1. So k T10 plus k. Hey, over here we know what k T10 is. It's natural log of 11 over 15. Let's bring back down this. So natural log of 9 over 15 is equal to k T10. We swap that out for natural log of 11 over 15 plus k. We subtract natural log of 9 over 15 minus natural log of 11 over 15 equals k. Now at this point we could just punch that into a calculator, or we could remember the properties that we know if we want to do a little bit less in our calculator. So that's natural log of 9 over 15 divided, because subtraction outside of logarithms becomes division inside, 11 over 15. So since we're dividing by 15 on the top and the bottom, they cancel out, and we're left with the natural log of 9 over 11 is equal to k. We take the natural log of 9 divided by 11 in our calculators, and we wind up getting negative 0.20067 as our constant for k. Our proportionality constant of k is negative 0.20067. Great! That means we can now take this piece of information right here. We know what k is. We slot that in over here. We've got natural log of 11 over 15 is equal to negative 0.2, sorry, I accidentally wrote an extra 0, negative 0.20067 T10. We divide by that. We've got natural log of 11 over 15 divided by negative 0.20067 equals T10. So T10 is equal to approximately, sorry, it comes out to be exact, well, not exactly, but we'll truncate it, we'll cut it down to 1.5, cut off some of those decimal places, we'll round it to 1.5456. So it comes out to be approximately 1.5456. However, they asked for the nearest tenth of an hour, so that winds up being about 1.5 hours. Now we want to know, what time did the person die at? When did the person die? Well, if at T10, that's the hours to get to 10 p.m. from time of death. So if it's 1.5 hours to get to T10, then that means death occurs 1.5 hours before T10. So we know that 10 p.m. is 1.5 hours after death. So if we go back 1.5 hours from 10 p.m., we get 8:30 p.m. as time of death. Great. And this idea right here, this is actually a basis for something that, real detectives, real medical examiners can use, this sort of idea of how these things work out. Math has a lot of really powerful applications, and this is just one example that's, something that's almost out of a detective story. All right. Cool. We'll see you at Educator.com later. This is the end of logarithms and exponential stuff, so we're going to move into a new topic. I hope everything here made sense, because it's time to get started on something else. All right. Bye.